Every random variable is associated with a probability distribution, just like the example I provide in my video on random variable. It is common to define discrete random variables in terms of their probability mass function and continuous random variable in terms of their probability density function, and both variables can also be defined in terms of their cumulative probability distribution function. To give you a more clear understanding about probability mass function, probability density function, or cumulative distribution function, or in general probability function, remember the concept of function in math. If you draw the probability distribution, you will get a curve like this or a smooth curve like this. The curve can be defined as a function. If the random variable is a discrete random variable and if the random variable is a continuous random variable. If the random variable is a discrete random variable, the function is called a probability mass function. And if the random variable is a continuous random variable, then the function is called a probability density function. And these two represent the form that is resulted from a probability mass function and the form that is resulted from a probability density function. And the last, a cumulative distribution function can be applied for both discrete and continuous random variable, because what we want to know is the probability between a range of random variables. So here we want to find the probability of x if x is smaller than a specific random variable, or if it's greater than a specific random variable, or it can be between a range, between a range of random variable 1 and random variable 2. Now let us focus our discussion on discrete probability distribution. There are two key properties of discrete probability distribution. The first one is the probability of each random variable, or x, is between 0 and 1. So here the symbol says that the probability of each random variable equals to x is between the value of 0 and 1. And the second one, the sum of the probabilities equal to 1. So the probability for a random variable equal to xi, if you sum it up, it will equal to 1. Now, let us see whether the probability distribution of our case, the numbers of family in India, fulfill the properties of a discrete probability distribution. Let us see from the table here. This is the random variable. And the first property says that the probability of each random variable is a value between 0 and 1. So here you see the probability all are between the value 0 and 1. So the first properties are fulfilled. Then the second property says that the probability of the sum of the probability of each random variable will equal to 1. And here this number indicates 0.05 plus 0.09 is 0.14. 0.14 plus 0.12 is 0.26, and so on. You can pause the video and see the summation. At the end, if it's equal to 1. So we can say that the probability distribution of our case, the number of family in India, does fulfill the properties of a discrete probability distribution. Now you should have understand the basic terms in discrete probability distribution. Now let us use the information of this discrete probability distribution using the family member India case to grasp some knowledge about the likelihood of a random variable to happen. So let's answer this first question. What is the probability that a random household has exactly 3 members? So if we symbolize it, it would be the probability that x equals to 3. Just by looking at the table, the answer is 0.12. So there's a 12% probability that a household in India has 3 members. Let's try the second one. What is the probability that a random household has exactly 7 members in a household in India? The answer is, make the symbol first, p, x equal to 7. Let's look at the table. When x is 7, then the probability is 0.07 or 7%. Now let's see the next problem. What is the probability that there are less than 5 members? Let's make the symbol first. P, x is less than 5 member. This is a cumulative probability, so the answer is px equals to 1 plus px equal to 2 plus px equals to 3 plus px equals to 4. We just need to count up to 4 because the question is less than 5. If it is less than or equal to 5, then 5 is included here. The answer, let's look at the table. Px, when the probability when x equal to 1 is 0.05, when equal to 2, 0.09, 0.12 plus 0.24. Result is 0.5 or 50%. We can conclude that the probability that there are less than 5 members in a household in India is 50%. The next one, the probability that there are 5 or more members in a household. 5 or more before we work on less than 5. So we can use the complement rule here. If we make the symbol px 5 or more is equal to px equals to 5 plus so on plus px equal to 8. Since we have work on 1 to 4 and the rest is 5 to 8, we can just write is just equal to 1 minus px smaller than 5. So it's also 50%, 0.5. Now the next one. What is the probability that the number of members in a household in India is more than 1? So the symbol would be px more than 1. It is px equals to 2 plus px equals to 3 plus so on px equal to 8. Rather than you just sum 1 by 1, you can just write as 1 minus px equal to 1. 1 minus 0.05 is 0.95. So there is a 95% that the number of members in a household in India is more than 1.